In this video, we are going to make a Chainlink request over the Ropsten network to one of the Honeycomb APIs. So to speed up the process, I did some of the starting work. So we went to the weather endpoint of the World Weather Online and we called the weather for Berlin. And as you can see, it is returned as data, current condition, a list starts, and there's a temperature in Celsius. We're going to come back to this, but now we know that this API works like that. The next thing that you should do is you can clone this repo as such. Let me delete this, and you clone it as such, and then you feed into it and say npm install to install the dependencies. I'm not going to do that here because I don't want it to take time. Instead, here is one where I have installed the dependencies, and I'll say code, which is going to open Visual Studio Code. And another thing that you should do is create a wallet.json file in the form of wallet.json.example. And here you can enter your inferior credentials or whatever HT wallet you are using, mnemonics and a URL. And I have already entered them into truffle config so that you'll be able to connect to Ropsten. So other than that, this is the exact same contract that the Chainlink truffle box comes with. Obviously, this project is based on that. So the first thing that I'm going to change is the Oracle payment. So if you look at here, I'm going to connect to the Ropsten network, and I'm going to, since it is temperature, I'm going to get it as an integer, right? And the price is 0.1 link. So if you don't want to send too much, we can say instead of send one link, send 0.1 link. And other than that, this contract is actually for calling a public API using HTTP GET or HTTP POST. Or maybe you can pass API keys through the header, but basically, if you are using an external adapter such as us, you would use copy path here instead of path, but the times would remain the same, but we're going to feed in 1 as times because the temperature that the API was giving was already rounded. So we don't have to multiply it with anything. So this URL parameter is no longer relevant to us, but we have a Q parameter, so we can replace these with Q. And say Q here. So that's all we are going to change. Oh, we are also going to change the data type. So here the return data is unsigned integer. We are going to get signed integer, and we also have to change these in other places, such as here. I guess that's all. Let's search. Integer. Yeah, that's it. Then we are going to have to change the migration. So this is for deploying to a private network if we are going to use Ropsten. So there's already a link token on Ropsten, obviously, and also we are going to use our the oracle from the honeycomb market, so we don't need this. So let's say 2 here. We don't need these. And I'm going to I like using this. Let's say await. And here for the link token address, we need the Ropsten link token. Ropsten link token address. This is it. Starts with 20. For the oracle address, we are going to use this. So basically, you can change the oracle address in this. We don't need that one. And after that, let's say await my contract deployed. And then let's, it actually writes this somewhere, but it is easy to print it. So let's migrate. Okay, we're done. We have deployed the contract, and this is the address that we have printed. So this is our truffle script to test the request. So we are going to fill in some stuff first. For one, we need to enter the contract address here. Then we need to enter the link token address, which we had here. And we also need the job ID, which is here. And let's save this. So let's go over the code first. So what we do is first we get the last block, the last Ethereum block, and it's going to be clear why. We get the requesting contract, and we get the link token contract. And the first thing we do is we send the requester contract enough links so that it can do the request to the node. So one way of doing this is you can send the contract a lot of link for it to do all the requests, or as here you can send it just before doing the request the exact amount that is needed. So here we are sending it 0.1 link, which is that exact amount. Then we create a request with these parameters, which were here, if you remember. It is this function. So job ID, queue, path, and times. And if you look at here, job ID, queue, path, and times. And job ID is this. We got it from Honeycomb. Queue is Berlin. Copy path is this. We got it from. Is it still there? No, it's not. So we got it from the response format. It was under data, current condition. And there was a list, so we index it by 0 and say temperature in Celsius. And times is 1 because we want to multiply it by 1 before returning it, because it was already rounded, so we don't need to multiply it by anything, which is why we are feeding in 1 as times. Then we create the request, and we go into an infinite loop During that, we are listening for events from that contract with the name Chainlink fulfilled, starting from the last block that we got here so that we don't listen for earlier events. And then we go through all of the events and we compare the request ID of that event with our request ID. And if those two are equal, that means that this Chainlink fulfilled event is actually belonging to our request. And then we break from this loop and we print the result. Temperature in Berlin is temperature.toString. So let's run the script. It is going to take some time because we first send the link, then we make the request, it waits for confirmations, then it fulfills the request, it waits for some confirmations. So this process takes a minute or two. So it is sent. Now the requester contract is creating the request and calling that create request while sending it the .1 link. So here it is. We get the job ID, the requester contract, the request ID, how much is paid for that, all that. And we're checking if there's a Chainlink fulfilled event every 5 seconds. So each of the 3 dots means that 5 seconds have passed and the job isn't fulfilled yet. So by default, you have up to 300 seconds to fulfill the job. Like listening to events is better than just trying and hoping that it is fulfilled. At least you know that it is actually fulfilled. So it says request is fulfilled, temperature in Berlin is 22. So if it wasn't fulfilled, it would show 0 because it's initialized at 0. And if I made another request but didn't wait for it to get fulfilled, I wouldn't get the new value but rather 22. So it's important to wait until your request is fulfilled. And here you see the Chainlink fulfilled events details right here. So if you need that, you can look at that. But basically now we have the temperature in blockchain to do whatever we want with it. So that's all. We are planning to provide some more detailed tutorials in the future, but I think this will suffice for the moment. Thanks for watching.